You guys remember the direct die problems I talked about when I was doing the EBJ build, how some of the contact was poor on the EK water blocks and it was like a widespread problem on Reddit? Well, after I made that video, I got an email from Singularity Computers. And they were like, hey, we had the same problem, so we came up with our own. But this one works on both AMD and Intel. This isn't sponsored, I just want to look at it.
We interrupt this video to bring you a special message from iFixit. No, we interrupt this interruption with this interruption about new stuff from iFixit. Wish you had a new graphics card, but inventory sucks? Fix the inventory problems with iFixit. Whoa, don't drop it. Can't fix that with iFixit. Just kidding, yes you can. Wish you could take iFixit with you anywhere, but your pockets aren't big enough? Introducing the new More
and the new Minnow.
Take them with you anywhere. So get iFixit for your loved ones, or just get them for yourself.
I mean, I said it's not sponsored. They did send it, but there was zero in expectation. They were just like, here you go. This is what we came up with. But what's truly unique about this is the fact that it is a single block that works with both AMD and Intel. With being very different socket types, that's kind of an endeavor. But they didn't give me any instructions on how it goes together or anything. So we're gonna figure this out together. I just happen to have a delidded 7950X3D. That's the one that I delidded, and then I was scared to try and use it in my build because I didn't know if it worked or not, so I just ended up going with a lidded one. And then here's my 13900K, which was gonna go in the EVGA build, which I ended up not using because of the direct die block issue. I think what's shocking me about this block right now is it's so small. Like, it is very small. Like, look at this. It's such a basic design, but you know what? How big does it need to be considering it's touching the die directly? I don't think inlet or outlet even matters because you can see it's just a straight cross flow. As far as I know, this is the first water block that, oh look, you can see they've tested this one. You see there's mounting marks on there. If I kind of move this around in the light, you can actually see the marks of where it was mounted. So I like that they've tested that. This is a prototype though, it's not out yet. But the square obviously has to be large enough to fully touch the Intel die, so it looks like if you put them side by side, it does look like the part that sticks down on the block will barely cover fully the Intel, but it's also a square instead of a rectangle because you've got the chiplet design for AMD. So you got the IO die, and then you've got the two CCDs, as long, obviously with the memory controllers and stuff built in. So you've got to touch both. Now, when it comes to mounting this down, we have AMD AM5 standoff kit. We've got Intel 1700 standoff kit. Mounting fasteners, which I assume works for both. Here's the thing that concerns me. They're just regular ass screws. So I don't know how we're supposed to mount this down. Oh, and then we've got a spare gasket, which is just the O-ring built into the block. So I don't know how we're supposed to mount this down and get even pressure. I really, really don't. That's the problem with direct die, is if you don't have a perfect length screw that has threads that stop so that you can have even tension on it, if you tighten up one side too much, then it goes crooked. And then that side can't tighten down all the way because this stops it from going up, so you get this cantilever action. So that's why I just want to kind of test it and see. So let's start with Intel. And my AMD board is an X670E from Asus. Not sponsored. I don't have any other AM5 boards. I'm just realizing this. I don't. I had one Tai Chi board with an ASRock board, and that's on our test bench. So stop yelling at me like, I thought you'd cancel Asus. We did fire them as a sponsor. They didn't sponsor this. I just have it. So stop complaining. Oh yeah. The block does mount directly to the back. So we do retain the backplate piece. But that's gonna make putting it together very cumbersome because I'm gonna have to sandwich the CPU in between the backplate and the block. Like that, and trying to screw it all in without damaging any pins. What could go wrong? That would be sad if this motherboard I accidentally brought back to life, which, by the way, if you guys are wondering how it came back to life, apparently what happened was the short that we caused with the backplate by dropping it behind the motherboard probably reversed or charged the caps up in some weird way that freaked them out, or even negatively charged them. And then when I put my multi-tester onto resistance, which provides a little current to the thing, and when I touched the EPS power on the back of the CPU, freaked out the OCP in the power supply, which is why it was clicking on and on and off. But doing that somehow reverse charged those caps back to the positive state they're supposed to be in, which then made it work. So 2 J wrongs made a right. You know, Louis Rossman's right. It's just not fair. It's just not fair that I continue to work my way out of these situations that I deserve to be in. I mean, at least the nice thing about, if I don't move it right now, all the threads back there are still lined up. So the CPU is just chilling in there, obviously. Oh, dang, and the extra component to this, which sucks, is the thermal paste has to be applied right now too. But it should all just line up. Oh, no, wait, I'm an idiot. Jay, you're dumb. The retention stuff should hold that in place. And then these should bottom out. Okay, theoretically now, these standoffs, which do look like they're just sourced regular standoffs, should, within theory, just hold the height where it needs to be. If the standoffs are somehow machined at the end to be exactly right, but I don't know. And then we've got these, unless these little washers here, no, these washers are just to protect the motherboard. There's these little white washers. That just has to be to protect the motherboard because there are traces and things around those holes. So as long as I get one of these started, I should not have to then hold it in place. I'll do that for all four. I'll just snug them up. Although when I go to tighten the water block, obviously it's gonna tighten on these. So I need to make sure these are tight enough to the back plate. Otherwise, when I go to take them off, they're just be like on motherboard or cases if you don't have the standoff tight enough and you have a tighter friction fit between the motherboard screw and the standoff versus the standoff and the case, you just take the standoff off with it when you go to take it off. If this works, and I'm not doing temperature testing with it today, I wanna do that separately. I just wanted to kind of see how it all works today. If this ends up working really well, without even the hold down thing, which to be fair now, the only point we have pushing down on, look at the die size versus the substrate size. And if you look at the substrate, you can see the pins go all the way almost to the outside. So the issue with the 12th gen and 13th gen is with the temperature cycles, this substrate was starting to curl. And as it curls, those pins, basically these are just like spring pins or pogo pins on the socket. They won't make good contact anymore. There's nothing holding down the edges. Whereas the full hold down plate that like DeBauer came up with, which is what EK was using, does hold the whole thing down. So I'm a little concerned right now that this might have been an oversight on Singularity Computers' part. Now this is, again, like I said, just a prototype. But these are kind of things that you have to consider, obviously, before you get it out in the wild and then you realize, oops. And because this is a direct die CPU, I have to get full coverage on the die. Otherwise, we'll have die hotspots and then we'll have dying dies. So I'm using my iFixit, or not iFixit, wow. My Linus Fixit screwdriver that I made at LTX because apparently we lost the bit from our iFixit kit chilling out here, which is the right size Allen key. Way to go, guys. And by guys, I mean all of us, because who knows who it was. Anyway, these holes are elongated too. I want to point that out. And I think the elongated holes are obviously so that it lines up with both the AMD and the Intel. I also forgot to point out too, there is downfire RGB lighting. So the RGB shines down and obviously through the acrylic too. But I just wanted to point that out. There's no switches or anything on here. Oh wait, there's a switch right here. So we have UV or RGB. So it's got a UV LEDs in there and RGB, which is an accessible toggle switch right there on the side. So that's kind of neat. Ooh, I can feel it like pulling against each other. So I really don't know how far I'm supposed to, I don't know if I'm supposed to go into these bottom out or what the deal is. So we're gonna find out together, I guess. And if we hear a we know we went too far. So the reason why I put thermal paste and everything on there, even though I'm not gonna fire it up right now, is I'm testing spread. Realistically, I would have to do this, I think with like a inch-pounds wrench and make sure they're the same on all four corners. That's the only way I'd be able to determine that it's flat. This could absolutely be crooked right now for all I know. I appreciate the size of it. It's not huge. I'm not a fan of the aesthetics, to be honest. I'm not a fan of clear acrylic like this. This reminds me of like some old Danger Den stuff that used to exist, where Danger Den had bare copper underneath, so you'd have the bright copper showing through. It just really feels Danger Den-like. So that's mounted down. It was simple enough. This would be very difficult to do if it were still in a case. I feel like a bigger, maybe more aesthetic thing would be kind of neat. But anyway, with that said, let's now take it apart, take it off and see what the die spread looked like. It was pretty obvious when I took apart the EK one that it was crooked on one side, because what we're looking for here is where the paste spread out to the point where it's so thin you can see through it. to the metal. And if there's any parts that are thick and globby is where it did not get full pressure to spread it out. So even loosening it up right now, if it kind of comes off like a saucer, you know, that's not enough pressure to spread the paste like we're talking. So I just want to point that out. If you're just going, but Jay, when you take it off, you could be moving the paste around. Yeah, it's gonna move to some degree, but not spread. Here we go. Wow, okay. That clearly spread. That's better than the EK was, that's for dang sure. You could guarantee that was gonna cool fine. So the EK had a whole bunch of like on one half, just I don't know, maybe we could show the old footage here, but it was all like on one side it was super spread out like you see, and on the other side it was thick, which told us it wasn't getting great thermal paste spread. But that is very uniform. That's very uniform. And we see it spread out one side more, and that's because when I was tightening it down, clearly it did this like kind of a roll function. That's why it spread out to one side. We don't care that we rolled it down. We care that it ended up flat at the end. And if anything, rolling it down instead of straight down would probably look like it helped the spread a little bit. That is excellent spread. It's a little bit aligned towards the top of the block, like in that little square. I don't know, because if you look at the elongated holes, it can move this way, technically, not this way. So I'm a little concerned about how close the edge of the die is to that lip. Actually, on closer inspection, the die itself is not centered on the substrate. So what we think now is the block has the maximum amount of tolerance built into it to be compatible with both CPUs. And it seems like the Intel one's the one that barely fit within that parameter. So not a Singularity thing. I don't know if they could have made that slightly bigger or if they have calculated exactly where it can end and not interfere with AMD socket, because the AMD socket is smaller. That whole system is smaller than the Intel. Initially, Intel appears to have passed until I do a follow-up with actual temperature testing. I kind of wish I had two of them because I'd love to have them set up independently. One Intel, one AMD. So let me clean this up. Let me put my Intel socket back together. And let's see how it goes for the AMD stuff.
NZXT's Build is a quick and easy way to get a new gaming computer. Build a gaming PC on your budget using the built-in configurator and see exactly how your favorite games will perform. Don't want to spec it yourself? Then choose from BLD's pre-configured player PC systems designed to fit your needs and budget. To see the full lineup and specs of the NZXT BLD Player Series pre-built PCs, follow the sponsored link in the description below.
So you can see the socket for AMD here now that they're LGA, which is land grid array. It's much more square than Intel currently is, and as I already showed, their die layout is also square rather than one rectangle. So they've separated out the chiplets and the I/O controller, whereas Intel, it's all on one die. So that's the major difference here. All right, so you have to remove the completely useless AMD spring retention system for coolers, which is honestly the worst design ever, but you have to hand it to a company that has kept continuity for decades at this point, but whatever. These clearly are not needed in our instance. And we will be retaining the backplate because we have to remove the main socket too. It's gonna be just like the Intel, where after we take this off and then we take off the Torx that are surrounding the socket, it's pretty much the same as the Intel. So you can see the bracket is sticking up through right there. It's being held on though by these four that are surrounding the socket. So now we're basically just like the Intel. Like it's very, very similar. I guess there's only so many ways you could do LGA, right? But it's even the same exact bit that you need for the Intel one. What I like about the AMD one though, is it comes up in one piece, whereas the Intel one you saw was two halves. This one just comes up as one giant piece. So there we go. We are now in danger zone. Things are exposed. Not sexually in a weird way or anything like that. There's no washers or anything for this one because as you can see, there's pretty much just fits within the hole and then it only barely touches the kind of insulated surround, if that makes sense. This is actually very easy, which is appreciated because I want this kind of stuff to be approachable for people who've maybe never attempted to even put a water block on, let alone a direct die block. But this is really, why not use mechanisms that are already in place? Yeah, they get pretty tight, I think, when they're towards the back. That one's loose. Oh, they get tight. They bottom out, that's for sure. I can feel it. It seems like they bottom out a little more defined. Yeah, that's bottomed out. On the AMD standoffs. So my only concern is it just looks so tiny. Like we're caught in this whole like, bigger is better, bigger is more powerful. Average is cool too. I feel like it just looks so dinky in there. Dinky. And then you have these still chilling right there. So I feel like maybe a cover would be neat to like come with it. But this is a prototype. Maybe they're working on that stuff. Maybe they're like, hey Jay, aesthetic second, functionality first. Otherwise we'll have another like velocity direct eye block problem on our hands. So let's do this. Let's now take it off and see how well it's spread. Like I didn't hear, there may be, but I didn't hear about any feedback regarding the EK direct eye block for the AM5 issues. I don't know. I never used one. It seems like it's just an Intel specific one regarding the tolerances on there where something was wrong with the plate. In fact, EK actually told me when I talked to him at LTX, like, yeah, there's some revision stuff that's been handled or being handled, but I don't remember what the details were. It's not impossible for this to happen in manufacturing, honestly. It just happens. AMD again. Damn, how am I gonna do this now without it getting affected? I feel like every AMD CPU, doesn't matter, it's going to stick to your cooler. You guys remember all the AM4 and below that just pull it right out? So you need to try and just pop it straight off.
Maybe not over the socket. Oh!
It's fine. No, so I think we had pretty good spread. I just saw it kind of goop down onto the, across it right now, but you can see we got pretty good coverage. Like this, there's a little bit of a thick spot. There's some thick spots on there, so that was tightened fully down. But I'm looking at the die, and I care more about what's on the die than what's on the block. It does look like it spread pretty good, but it looks like we have a corner right here maybe where it didn't spread out fully. And I did tighten down the screws as far as they would go. Like I could tell that I was turning the standoff tighter in the back plate. So this, I don't know if this is just from when I picked it up. That looks like it maybe didn't spread all the way to the edge right there. Again, I can't hold this against Singularity because it is a prototype, but I wanted to show what they're working on. This is one that will be interesting to temperature test because I do feel like there's some issues on the, those are the CCDs. The big one is the IO die, memory and all that sort of stuff. So obviously if the CCDs are having direct contact problems, then we're gonna see that in performance. But anyway, that's all for today. I'm glad to see that one of the things that Phil said off camera is, I love the fact that there's a company or a person or entity that exists that can identify a problem but has the technical knowledge and the tooling and the manufacturing capability to address the problem on their own. So it's just, this is how products are born, and I love it. So anyway, I wanted to check out the prototype. When it's in final revision is when I think it's appropriate to do temperature testing. I don't think it's fair to do temperature testing when something's in a prototype state, because obviously in prototype they have not worked out all the bugs yet, or it would be considered final revision, which it doesn't say, it says prototype. So, all right guys, thanks for watching. Give Singularity Computers some love. They didn't sponsor this video, I just wanted to do this. You guys can go to Singularity Computers, they're down in Australia, arguably one of the best SIs on the planet when it comes to custom water cooled and custom builds. So anyway, Daniel, love what you do. Thanks for sending this. And everyone else, go and check them out. Thanks for watching. We'll see you in the next one.